So this is an Innovate UK project and it's been going 3 years. The goal is to bring together all these partners that we have here and produce a demonstrator which can act as a platform for an unmanned air system.
We've proven the philosophical concept of a variable buoyancy propulsion system for an aeroplane. So as far as we know, that's the first time that's been proved.
We've got a very large consortium of partners involved, so we have 3 catapult centres including ourselves, 4 SMEs and a large group of universities all involved in the project.
Relatively few companies, SMEs, universities and government catapults have been responsible for the creation of a completely new type of aeroplane, and that's a fantastic achievement, and yes, I'm very proud.
We've had a really go-get-it attitude, a lot of positivity all the way through. It's exactly the type of thing that I joined a catapult centre to get involved in.
The most inspiring thing for me is seeing a control system that we designed and ran in a simulation go all the way from testing there to be actually deployed on the aircraft that just flew. It's not often that I get to do that sort of thing, and that's been an absolutely amazing experience.
I'm really proud of what the entire consortium has achieved. I'm particularly proud of the NCC's apprentices, as this was entirely given to them to do in terms of manufacturing the wings and the tail box structure. So it's fantastic that something that they've been able to do this early in their careers has successfully flown today. I think it's a fantastic achievement.
Under autonomous mode, it can be left to its own devices. The ultimate aim is to have it at 20,000 metres. It's not at that stage at the moment, but once it gets that sort of level, it then becomes available for multiple uses. Low-level satellites, GPRS systems and surveillance.
By having solar panels on, it is completely self-sufficient in energy. So once it's up in the sky, it can stay there for quite a long time, so we can use it as a kind of pseudo-satellite.
With the small drones, battery life is several hours, where our aims was to have it aloft for several days. These sorts of vehicles can actually be taken up to the outer atmosphere and then release micro-satellites which then go into orbit. So the most expensive bit is getting them from ground up to the outer atmosphere.
There are several types of vehicle that could possibly do the same role, but they are more complex machines and more expensive. So having a cheap, almost disposable aircraft like this will mean that you can do things with it that you wouldn't contemplate with a more expensive machine. So yes, we're hoping that the next stage to take it onto a more feasible prototype would require input from industry, so that's where we're looking for next.